So if you've ever been to Head Smashed In Buffalo Jump, okay, you know that the Aboriginal people of our area used to hunt buffalo by running them off a cliff. Okay, you can do that because buffalo have a big, huge blind spot right in front of them. Because, like most herbivores, their eyes are on the side, so that while they're eating, they can see their predators to the sides. Okay, it doesn't work very well though if you get them running with their head down, because they don't look forward and they'll run right off a cliff. The whole bunch of them. Okay, so what we're looking at here is the physics of the fall, not the hunting part, which is still interesting, but not the physics part. Okay, so what we have is a big cliff, okay, and we're going to run these buffalo off the cliff, okay, and all we know here is that they are landing 75 meters from the base of the cliff, so that is a horizontal, horizontal piece of information, okay, distance is 75 meters. We know that their final vertical velocity, so I'll put vertical stuff over here, okay, their final vertical velocity is 36 meters per second, okay, and we're looking for how fast the buffalo is running. All right, what else do I know that the question didn't tell me? I know acceleration, and I know velocity initial. Okay, 1 mark for Givens. If I'm going to calculate how fast the buffalo was running, that's the horizontal speed, what else do I need? Time. All right, so I've got to calculate time using my vertical information because that's where I have enough information to do it. Okay, the formula I'm going to use is A equals VF minus VI over T. Okay, and I'm going to manipulate it for T, so it'll be VF minus VI over A. Give them a mark for that. Okay, and calculating our time will look like this: 36 minus 0 over 9.81. So really, it's just 36 divided by 9.81. Okay, so we are looking at 3.669 seconds, right? So we'll give them 1 mark for having the correct time, 3.669 whatever seconds. Okay. All right, so we're up to 3 marks. In order to get V, I've got to use V equals D over T, but I don't need to manipulate it because it's already set up to find what I need. So that'll be 75 meters divided by the 3.669 seconds. Give them a mark for that step. 5th and final mark will be for having the correct number for our velocity here. So that'll be 75 divided by our time, which is 20. And we only have 2 significant figures here, 20 meters per second. 5th and final mark. Questions on that one? Nope, I think you gave him, you can give him 1 for that. All right. For question number 2. Sorry, was there another question? No? Okay. All right, so for question number 2, we have a cannonball fired into the air at an unknown velocity and an unknown angle. Okay, so we've got this flight, okay, and we know that it reaches a maximum height of 78 meters, right? Horizontally, we know that the horizontal component, so V horizontal, is 85 meters per second. Okay, and vertically speaking, okay, we know that the maximum height is 78.0 meters. And what's the speed at that point? 0. All right, so I have that, and I also have acceleration, negative 9.81 meters per second squared. All right, so mark for Givens. What we're looking for is theta. If I'm going to get theta, I need 1 more side, all right, because I already have the adjacent side here. The question told me it was 85 meters per second. So I need at least 1 more side. I would say my best chance is to get this side here. All right, get V initial from the information that I have, because I have D, I have VF, and I have A. So I should be able to solve for VI. All right, so I'm going to solve for VI using VF squared equals VI squared plus 2AD. So you can give them a mark for choosing that formula. All right, so manipulated, that's going to be the square root of VF squared minus 2AD. Right, with numbers plugged in, that's going to be 0 squared minus 2 times negative 9.81 times 78 meters. All right, so we're going to have the square root of 0 minus 2 times negative 9.81 times 78. All right, so I'm getting that my initial vertical velocity was 39.11 meters per second. I can have a mark for that. Now we've got to calculate theta. Okay, so our last 2 marks are going to be for doing that. The trig function I'm going to use is tan. All right, I know that the tan of theta is the opposite side divided by the adjacent side. Those are the sides that I have. All right, so if they showed that, or they showed that theta equals tan to the minus 1 of the opposite side, which was 39.11 divided by 85. Okay, either one of those can be good for their fourth mark. Okay, and that'll give us theta. All right, so second tan of our answer divided by 85. All right, so we're looking at an angle of 24.7, but we only have 2 significant figures. So we are looking at 25 degrees as our final answer. Okay, and I'll accept just 25. If they wrote above the horizontal, that's even better, but okay, 25 degrees will be good for their 5th mark. Give them a mark out of 10, let them see it, and then I'd like them on this desk right here, please.